Hi, I'm Mukul Agarwal representing the programming group of B.E.S.T Team 58 from Allen High School, and this is our submission for the Simulink Design Award. To switch between the autonomous and driver control phases, we used two enabled subsystems, one for each phase, and used a latch along with the 7 down button, effectively allowing us to use that button as a toggle to switch between the two states. This is our drive subsystem. Insofar as actually driving the robot, we decided that since our robot has two sides, each with certain features, we could have an invertible drive system. So we had a driver-oriented rather than a robot-oriented drive system, which our drives found very useful, and we used this subsystem with two switches and some other varied blocks to kind of abstract the logic of the driving. We also used the two deadbands to avoid low power being sent to the motor, causing a large amount of noise with no real movement. For the tower stabilizer, we used two servos that were oriented differently, so their values are supposed to correspond insofar as position and would normally be the inverse of each other. However, we noticed that some servos were not calibrated perfectly, so we used slightly different constants to achieve the same intended physical result. For the air compressor, we decided to use these two, this similar setup. We also used a feed forward of 12 to keep the air compressor from collapsing. For the elevator, we used this system. We also used feedback from a limit switch so that our drivers could simply press the 5-up button to go up and not worry about stopping at the right height, since that was handled by the limit switch. For the pipe collector, we just used a simple toggle to switch between the two states. For the light pole release, we used a counter, so the system turned by a certain amount every time the button was pressed, and it could reset back to its original location. We also used the 8-up button combined with a pulse generator to allow us to wiggle the release mechanism to ensure that the light poles were able to leave the holder on the robot. For our autonomous period, we used a stateflow, and that was connecting to each of the designated outputs here, and this is our stateflow chart. Thank you. That's the end of our presentation.